Hello everyone, I hope everyone is doing wonderful as always. Today we are going to solve this question from LeetCode, which is going to be maximum depth of binary tree. So let's understand the question first. Given the root of a binary tree, return its maximum depth. So we have given a binary tree and then we need to return a maximum depth. Now what is a maximum depth? Well, the maximum depth here, it says it is a number of nodes along the longest path from the root node down to the farthest leaf node. So if you see it here, this 3 is our root. Now we have to go farthest down to the leaf node, which is this 7, to find the maximum depth. Now in this case, our maximum depth is going to be 3, so because 1, 2 and 3, right? Starting from the root node, you have to go to the leaf node and it has to be the farthest leaf node. You don't have to go to on this one and then say that that's the maximum depth. You have to go to the longest leaf, or you can say the farthest leaf from the root, and basically you'll be simply counting the number of nodes and then returning all of those nodes from root to leaf. So that's how you will be finding maximum depth of a binary tree. Now before directly jumping into code, we have to understand a bit of this by simply explaining a bit. Okay, so as I stated earlier, maximum depth means a number of nodes on the longest route to leaf path. That means if you see it here, this is our route, right? Since 3 is our route, this is also a leaf because it doesn't have any child afterwards. So that means it is a leaf, but that doesn't mean that is our maximum depth, because it says that starting from the root, you have to go down, and then you have to find the longest path, and then that leaf has to be the farthest one from the root, which is this one, right? So this is the leaf that we will be checking, and then we'll simply be counting the nodes. So this is one node, this is second node, and this is third node, right? So our output will simply be 3. So that's the maximum depth of a binary tree. Okay, so how would you actually solve this problem? You now know how to solve it by just seeing it, but how to solve this problem by using a code? Well, if you want to solve this, you need to know one or two things first. First of all, you should be familiar with traversal techniques. There are a lot of traversals, which is pre-order, post-order, and then the last one is in order. In this particular example, we will be using this technique, which is post-order traversal. So what is exactly a post-order traversal? Well, a post-order traversal is basically defining a function and then going to each node, or you can say simply from here, simply you will go to this first node and then go to its left node and then go to its right node, right? Now again, from this particular left node, we will go to its left and then right, and then only print the value. So basically we will travel our left subtree, right subtree, and then go to the root itself at last. So that is how post order traversal works. So how are we going to combine post order traversal to find the maximum depth of a binary tree? Well, if you see it here, we have to complete this function, which returns integer. So I'm simply copying that function in the whiteboard. Okay, so let's write here, which is integer maximum depth, right? And then I assume it holds a root tree because the tree should be given in order to traverse it. Now what if you only have one node? Let's say you are given one node, which is 2, and then question asks you to find a maximum depth of a binary tree. Well, this is simply not a binary tree. I mean, one node can simply not be a binary tree, but let's assume that you have only one root, right? In that case, you will simply return 0. So you would say here, if root equal to null, then return 0. Now, using the technique of post order traversal, you will go to your left node first. So you will simply call this max depth function again, and then call your root's left value. After you call your left subtree, you will again use the same technique to call your root's right value. Now, as soon as you do that, what happens is, let's say you had a binary tree like this, which is 2, 3, and 4, right? Now, initially your root is 3 here. You will check if your root is null. Your root is not null, and then you will go to this function, which is max depth, and then it will call the left value, right? Now in this is holding uh sorry, this is 2, this is holding 3, and then this is holding 4. Now it doesn't go to this function recursive call immediately. First of all, this function call should be executed, and then only we will call this function. So whatever value we get from here, and then whatever we get value from there, we'll simply add 1, and then we'll simply do maximum of, we can simply write integer left here, and then we can simply write integer right here, because these will return some value, right? And then simply do left and then right. Now we need to simply check, why did I do maximum of left or right here? Well, I'll simply give an example here. First of all, let's traverse this, right? Since this value is 3, and then right now our function is here, it will check if root is not null, then again this function will be executed, and then root's left, it is null, so null will be called, and then this function will return 0. So left is holding 0 right now. This left is holding 0. Since this returns 0, we will go to the right function, and then call this max depth again with our root right value, which is also null, and then this also returns 0, right? Since left and right both holds 0, this from this here, this will return 1. Now why does this return 1? Well, the reason it returns 1 is because this leaf node is simply 1, it contributes to 1, that is 1, right? So if you think about this branch on the left side, it has one node, so it has to take care of itself. That's why it is doing 1 here. And then the reason we do maximum of left or right is because we need to find the maximum depth of the binary tree. So let's say here left tree returned 1, right? For an imaginary binary tree. And let's say right was 0, right? We will simply return 1 from here, because that left leaf node is contributing to the answer. That's why it is going to be the left subtree. I hope you understood the problem. So let's quickly transform this code into the actual LeetCode answer, and then we'll try to submit it. We'll check if our root is equal to null. In that case, we'll simply return 0. We will, if not, we will call the maximum depth with its left value, and then again call the maximum depth with its right value, and then call this integer left, and then we can call it integer right. As soon as we do that, we will simply return 1, and then maximum of left or right. I think this should run, and this should be it. Let's try to run it. If this runs, then yeah, that's it. If not, then we did some error. Yeah, it successfully runs. That means we did everything right. Let's try to submit the question. Okay, so we were pretty good, so it beats 100%, and then that's it. So let's try to dry run this a bit in here. Okay. I'll try to dry run it on the example, this particular example, 3 9 20 15 7. Okay, let's draw it here. Sorry about that. 3 9, what is it? 20 15 7, 20 15. Okay, 7. So this is our binary tree initially. Now this is the root, and then our function call is here. We will simply, in our first recursion call, so this is our first recursion call, we will call roots left, which is 9, and then roots left will again call its left and right value, which is going to be null, and it will also call for its right value. So I'm talking about this particular node. It will call both its left and right, which is null. So null, since this returns 0, this returns 0. Now after that, this line will be executed, 1 plus maximum of left and right. So simply we can simply return left equal to 1. So I'll erase everything here, and then write 1 here. Now as soon as we execute that, our function call goes back to this particular thing, and we have returned 1 from left side, and then it will go here. Now it will call its right function, which is 20, right? Now 20 will call its left node, which is 15. 15 will call its left and right node, returns 0, or we can say return 1. So this node holds 1. Now since this node called it left node, it also has to call its right node, and then it returns 1 here, and then it will take 1 plus maximum of 1 and 1, which is going to be 1. So it will return 2 to the root node. So we will have to return 2 and then return 1. So it will compare which is the maximum value. Since 1 and 2, since if you compare 1 and 2, you will get 2 is the maximum value, and then add 1. So your value will be 3. So that's how you traverse and get the maximum depth of a binary tree. I hope you understood the problem. If not, you can rewind the video again and try to understand it by try running multiple times. Thank you so much for watching the video.